Okay, we're going to go ahead and verify yet again another identity, and these types are pretty unique in that, as you can tell by the title, it's working with each side separately. Now, at the beginning of this unit, I told you that you can't work on both sides, and what I meant by that is you can't, so like you can't add one on this side, add one here, so kind of like we would do like with an equation. Verifying identities means you work with only the left side, and does that equal the right side? But what this is going to have us do, or the way that you verify that the left side really does equal the right side, is you need to simplify the left side until it's in its most simplest form, and then stop there, and then simplify the right side, and then you're going to see that they're going to be the same. So we're still working with each side separately. We're not mixing the two, and that's what you can't do when you're verifying. You can't times this side by sign times that side by sign, but you can just work with just one side at a time, and if you get both of them to be equivalent, then you know that you verified correctly. So let's start with the left side, and then we'll go on to the right side here. So we want to simplify this, okay? And maybe you're thinking, oh, we'll multiply by the conjugate. Well, we could do that, but I'm thinking that since cotangent squared is one of our Pythagorean identities, cotangent squared is cosecant squared minus 1. So I'm going to go ahead and replace cotangent squared with cosecant squared, and that's going to be minus 1. Okay? And that's all over 1 plus cosecant theta. Now, this right here is a difference of two squares. Think of this as a squared minus b squared, where my a is cosecant, so that means cosecant squared minus 1 squared. Well, we know that if you can write it as a squared minus b squared, then that means our factored form of this is a plus b and then a minus b. So that's what I want to implement right here. This right here, think of this whole thing as my a, cosecant of theta is my a, and 1 is my b. So if I factor it, it's going to be cosecant theta minus 1 and cosecant theta plus 1. See that there? So if I factor this, it becomes cosecant theta minus 1, cosecant theta plus 1. My denominator is 1 plus cosecant theta. And now that's nice because look at what happens here. The 1 plus cosecant in the denominator can cancel out with one of the other factors, cosecant theta plus 1. And then we're left with just cosecant theta minus 1. Okay, so I've dealt with just the left side, okay, and I'm going to stop there because there's really nothing else I could do. I mean, I could change this into 1 over sine, but I'm going to leave this right here. Now I'm going to go to the right side, and I want to manipulate, change this around so that hopefully I can make it to be equivalent to cosecant theta minus 1. Well, check this out. Since the denominator is a single term, that means I can break up my denominator into two separate fractions. So I can, the equivalent of this is 1 over sine of theta minus sine theta over sine theta, right? So this right here is equivalent to that. Well, 1 over sine of theta is cosecant theta, and sine over sine is going to give us 1. Oh, you a trick of me. And there we have it. So in review, at times you're going to need to simplify both the left and the right side. Well, how do you know when you're supposed to do that? Well, you know when you're supposed to do that when you simplified one side and it looks nothing like the right side yet. You're like, okay, well, let me just maybe try simplifying then the other side and see what I get. And that just happens to be another technique in simplifying trig identities.